Welcome to this next lesson, which is on vertical and horizontal lines. We're going to start up with a warm-up, so here we go. Now find the equation of a line which passes through the points, these 2 points, -1, -2, and 5, -1, in gradient intercept form. So you probably realize you need to label that x1, y1, label the other coordinate x2, y2. In gradient intercept form, what we mean by gradient intercept form, we mean y equals mx plus c. So we need to calculate the gradients and we need to calculate the y-intercept. Let's calculate the gradient first. So remember the formula for the gradient, m equals rise over run, which is y2 minus y1 over x2 minus x1. Try to remember that. And now let's just plug in our numbers. So our y2 is -1, our y1 is minus -2. Be careful with your negatives. y2 minus y1, so -1 minus -2. x2 minus x1 is 5 minus -1. So try not to do that too much of the changing negatives, double negatives into positives in your head. So you can, if you want, you can rewrite that as -1 plus 2, 5 plus 1, which should give you 1 over 6. So we have a gradient because -1 plus 2 is 1 and 5 plus 1 is 6. So we have a gradient of -1 over 6. So we can rewrite our formula so far as y equals 1 over 6 x plus c. And we now need to work out what is our c going to be. So to work out what our c is going to be, we need to choose either that first coordinate, -1, -2, or choose a second coordinate to sub in. So I'm going to choose the first one. Maybe I'll choose the second one because it looks a bit easier. 5, -1. So that's your x and your y. So y is -1 equals 1/6 times 5, awkward, plus c. We're going to solve for c. So -1 equals, try to think what's 1/6 times 5. So what you can do is, if you're not sure, you can do 1/6 times 5 over 1. Gives you 5 over 6. So you can do that on the side there. So that becomes 5/6 plus c. So what's our c got to equal? C must equal -1, take away 5/6. If you're to do that without calculator, it would be -6 over 6 is -1. Take away 5 over 6. So that would be equals -11 over 6. So don't forget that's our value of c, and we haven't quite written the equation fully yet with the m and the c subbed in. So our final answer, we've got to write it in gradient intercept form. Y equals 1/6 x minus 11 over 6. So it's not till we've written this final equation that we've completed the answer. So again, make sure you don't just find out what m is and find out what c is. Make sure you do this final step where you sub it all in together. Next question in the warm-up. Find where the line 3x minus y equals 1 cuts the x and y axis. So they want you to find the x and y intercepts. And remember, the way I tend to do it is I set it all up in a table. Just a bit more space. So I tend to set it up all up in a lovely big table. I set it up like this. And I go x-intercept first. I go y-intercept second. So my x-intercept, y equals 0. I've written out the y-intercept, x equals 0. So now you just use your equation and you just substitute in y equals 0. So we can go 3x minus 0 equals -1. So that's 3x equals -1. So x equals -1 over 3. So our coordinates for that are -1/3 and 0. Now similarly, let's work out our y-intercept. Our y-intercept, we've got to sub in x is 0 into here. So we can go 3 times 0 minus y equals -1. And that becomes -y. Don't forget it's -y, not positive y, because 3 times 0 is 0, equals -1. So y equals negative 1 divided by negative 1, because that's like negative 1y. That. Y equals negative 1 over negative 1, so y equals 1. So our x-intercept is 0, our y-intercept is 0, 1. And there are our final answers. So that's 1 point where it cuts the x-axis, that's the x-intercept, and that's your y-intercept. So we have 2 answers here. Fabulous. So now let's go on to our next page. So now let's start the lesson. Reasonably easy concept. Horizontal and vertical lines. So remember, horizontal lines kind of cutting across like this. Vertical lines are kind of going downwards like this. So horizontal and vertical lines. As we said, horizontal going across, vertical go up and down. Try to think of what's a word similar to the word horizontal that you see in the real world. It's horizon. So you look out into the ocean, you see the horizon, and it's quite flat. So if you ever forget it, you can think of that. Horizontal for horizon. Now, what are the notes? Horizontal lines run parallel to the something axis. So a line like this would be parallel to the x or the y axis, do you think? That's right, parallel to the x-axis. And something starting with P to the y-axis. So this line, the y-axis would be cutting through. So this line, would you agree, it's perpendicular, meaning at right angles. So horizontal lines run parallel to the x-axis and perpendicular to the y-axis. Whereas vertical line runs parallel to which axis? The x or the y-axis? I think that's the y-axis. And perpendicular, therefore, to the x-axis. So vertical lines will cut the x-axis at a right angle. In the diagram below, for example, which lines are vertical, horizontal, perpendicular to each other? So, for example, here's line A going across here, here's line B going across here, and so on. So try to think which ones are vertical, have a think for yourself, and hopefully you got this answer. Hopefully you got D and E. D and E parallel to the y-axis. Horizontal lines, you've probably got 3 of them. I think what they would be. That's right, A, B, and C are your horizontal lines. Now, perpendicular to each other, one example is, for example, I said A and B, but they're not, they're parallel to each other. So I meant to say, sorry, A and D. So please change that to A and D, not B, because see, A and D are perpendicular to each other, whereas A and B are parallel. Sorry, that's a typo. So A and D, what's another pair? You can say B and D. You can probably also say C and D. You'll probably find another 3 pairs as well. So you also notice that there's A and E. I think what's another pair? You've probably got it. B and E. And one more pair, C and D. Great. So now let's move on to the next page. Pretty basic so far. So recap. What is the formula for gradient? So you probably remember from the warm-up, it's either rise over run, or in terms of coordinates, the rise is the same as y2 minus y1, and the run is the same as x2 minus x1. So they're your little formulas. Because they're little fancy formulas, I'm going to put them in yellow, just so when you look through, that might be helpful to see. So use the first version of the gradient formula above to find the gradient of the following horizontal line. So here's our horizontal line down here. Fabulous. Oh, my goodness. What's going on there? Can we do it? Can we do it? Yeah. Nice. Okay, so here's our horizontal line. So we can use x1, y1 and x2, y2. So we can call this one, if you want, x1, y1, call this one x2, y2. So the formula is already written above, so I'm just going to go straight to by filling it in. Y2 minus y1 is, y2 minus y1 is 5 minus 5. X2 minus x1 is 5 minus negative 5. So that's going to give you 5 minus 5 is 0. 5 minus negative 5 is 5 plus 5 is 10. Try to think 0 divided by any number. What will it equal? I think. correct, it will be 0. So interesting, you've got a gradient of 0. How about that? Now we want you to use the second version of the gradient formula above, the second one to the right, to find the gradient of the next horizontal line. So we don't have any coordinates on this one. So remember, m equals rise over run. That's what I want you to use of this horizontal line. So try to think interesting. What rise does it have? So it has no rise. So you would say 0 because it has no rise. Because it has no rise, the line there. And in terms of the run, we could say, it doesn't say where it's beginning and ending, so we could say infinity. Because infinite length horizontally. That's why, because we don't have coordinates. It doesn't. The top one, the one above, had a specific beginning and end, so that's not infinite. That's got a run of 10. Whereas this one doesn't define where it begins and ends. There's no dots to say it ends. So 0 divided by infinity, of course, that's just 0 still. So therefore, from this, the gradient of a horizontal line is always equal to 0. That's what we're found. So gradients of horizontal lines tend to always be equal to 0. Now let's look into verticals. So use the first version of the gradient formula, this one in blue, the first version of the gradient formula, on the previous page to find the gradient of the following vertical line. Use that vertical line. Oops. And instead what I'll do is, let's just undo that. Let's just say it's from, let's just cross out this bit. Let's ignore this bit. And let's just say that this vertical line, because I want to use the coordinates, that's why, in the gradient formula. So let's say this vertical line runs from there to there exactly. So this vertical line, we'll say, instead runs from here to here. So let's see, it's y2 minus y1 over x2 minus x1. Let's write that out. X1, y1, x2, y2. So y2 minus y1 will be 0 minus 2. X2 minus x1 will be 3 minus 3. 0 minus 2 is negative 2. 3 minus 3 is 0. And so try to think. Try plugging into your calculator. What's negative 2 divided by 0? Let's try it out. Okay, so negative 2 divided by 0. What do you think is going to happen? Undefined. How about that? And so it's all because in mathematics, you technically can't divide by 0. So undefined. That's what we write. So hence the little joke, only Chuck Norris can divide by 0. Only Chuck Norris can divide by 0. So in mathematics, we can't divide by 0. The reason why is technically, division is all about how many times you need to subtract something to get back to 0. So for example, 21 divided by 3, you don't need to write this down. 21 divided by 3 equals 7, because 21 minus 3 minus 3 minus 3 minus 3 minus 3 minus 3, maybe one more, minus 3 equals 0. So you need to subtract 3 7 times to get back to 0. But if you take something like negative 2 and you keep subtracting 0, you never get back to 0. So that's why dividing by 0 is something that doesn't make any mathematical sense. From there. So only Chuck Norris can divide by 0. So if you get something 0 divided by a number, that's fine. That gives you 0, but a number divided by 0 is undefined. So you have an undefined gradient. Now use the second version of the gradient formula on the previous page, so meaning rise over run. Use the second version of that formula, gradient formula, to find the gradient of the following vertical line. So notice I've made it kind of like infinite this time. It's got an infinite rise. Does it have any run? No, it doesn't. So again, it's just rise over run. The rise is infinite, and the run is 0. And same thing again. 0 divided by 0. We're allowed to divide by 0. So if you do that, you will get an undefined answer as well. Only Chuck Norris can divide by 0. So perhaps you remember. Therefore, overall, we can say the gradient of a vertical line, is always undefined. Gradients of horizontal lines are always equal to 0, and gradients of vertical lines are always undefined. So what have we learned from the previous 2 pages? We can fill this in. The gradient of a horizontal line is always equal to 0. The gradient of a vertical line is always undefined. Fabulous. Recap. What is the formula for the equation of a line? So you can remember, try to think, it's y equals mx plus c. A little formula. So let's give it a golden halo. So where m is the gradient and something is the something intercept. So and c is the y-intercept of the graph. So to recap these things. So find the equation of the following horizontal lines. Fabulous. So remember it's y equals mx plus c, in case we forgot. What is the gradient of a horizontal line always equal to? The gradient of a horizontal line is always equal to 0. So we can say y equals 0x plus, and what's the y-intercept? See the y-intercept? C equals this point here. C equals, it looks like it's negative 2.3, I would say, about negative 2.3. So plus negative 2.3, and 0x just becomes 0. So 0 take away 2.3, it's just negative 2.3. So that's the equation of a horizontal line. It's just y equals a number because the gradient's 0. Same thing again on this little one here. Again, y equals mx plus c. What's our m equal to? Our m is equal to 0 because it's a horizontal line. What's our y-intercept? Our y-intercept is right here, sorry. So y-intercept is 5. We can say our gradient is y equals 0x plus 5. 0x just becomes 0, so it's y equals 5. So equations of horizontal lines are always just y equals the y something which the line passes through, like the y value, or you can say the y coordinate. You can say the y value. It's the y value which the line passes through. You can see this one passes through negative 2.3. This second one passes through 5. So it's always y equals a number, and that number is the y-intercept. Similar for vertical lines, remember the gradient of a vertical line instead is always undefined, because you can't divide by 0 and the run is 0. Therefore, it's not appropriate to use y equals mx plus c for vertical lines because we can't substitute in an undefined gradient if it's not even there. It doesn't exist. So instead the equation will just be x equals, similar to the last one, the x coordinate. Vertical line cuts the x-axis. So x equals the x coordinate the line passes through. So it's like x equals 5, x equals 7. So the equation for these ones, they're just similar to horizontal lines are y equals because they cut the y-axis. Vertical ones cut the x-axis. So where does it cut the x-axis? It cuts it at 3. So it's just x equals 3 for that one. And for this one, where does it cut the x-axis? That looks like it's about, is it negative 1.8? So x equals negative 1.8. There you go. They're the equations of these lovely little lines. So as we said, horizontal lines, their equations are just y equals the y-intercept, and vertical lines, they're just y equals the x-intercept, the x-coordinate that it goes through. Isn't that fabulous? Okay, and that's the end of the lesson. Thank you.